goals or objectives for section 1.1. I collected data from a game called Pokemon Go. Maybe you've heard of it before. A couple of years ago, it was very popular. So I have some data here in the two-way tables. Some of my data is categorical, some of it is quantitative. You should know that from last section. So you can check it out, see if you can figure out which one is which. I'm only concerned with categorical data, and so I'm going to pick one particular one that I know is going to be a category. It's a type of Pokemon right here. From that, I'm going to come over here, and there's two types of graphs I can draw. I'm going to draw something called a pie chart or a circle graph and a bar graph. Now, when I draw these things, you want to make sure that they're able to stand alone. Every graph you ever draw, you want to make sure anyone could come in at any time, look at it, and understand what it represents. We're going to be using something called Statlet.com a lot this time. And for one categorical variable, I'll come in, Pokemon type. I'll put in all the different types. I'll come over here, put in the frequencies. It'll draw me a nice bar graph. Now, I can do frequencies, which is actually a count, or I could do relative frequencies, which just converts it to a percent. So if I want to create a pie chart, I click on here and it gives me a pie chart. If you have to draw one of these by hand, just make sure this is 45.5%. I would cut the circle in half and just do a little bit less and make sure that this is 45%. 25% is easy. Cut it in half, make it a quarter. Down here, 15 and 9. Just make sure the 15 is bigger than 9 and 9 is bigger than the 4. They don't have to be exactly drawn by hand. But make sure, all right, it's Pokemon type, water. I would just put them right inside each one if I was drawing this by hand. So they're the type of graphs we're going to use for categorical data. You can have bad graphs. You have to be careful when you're drawing graphs. For instance, look at this data here, and it says, all right, age group and percent of people owning MP3 players. It'd actually be 0 today, but this is some data that they collected before. 54% are between 12 and 17, 30 and 30. Think about why is that bad to create a pie chart. We're already over 100%, so there's no way I can create a pie graph of that data. I can create a bar graph, and again, if I was drawing it by hand, this is a beautiful example of what I would want your bar graph to look like. So take this. These are the same width. They don't touch. Your axes are labeled. Your scaling is on here. Makes it look, it's easy for anyone to read it and understand what it represents. That's what I'd want your graph to look like. Other bad graphs you got to be careful of, something like this with your scaling. You'll notice here that PC's it's a little more than half of this. Well, if you look at it over here, it looks like none is 4 times because they started at 10 instead of 0, so be aware of that. Another one is called the area principle. You look at none and you look at the Macintosh. This thing is really only supposed to be 4 times as large. It looks like it's 10 times as large because the area principle, the area of this thing is much bigger than the area of that one. So they're the type of graphs that we're talking about for categorical data. What else do we do with categorical data? We put it in two-way tables where, let's say we're interested in 2 different variables, categorical variables, gender and the number of times someone plays in a week. So we want to see if there's an association between these 2 things. So we can start to analyze it first by looking at the marginal distribution, which is the distributions out here. These are marginal distributions in the margin. There's 2 different marginal distributions. I have marginal distribution for gender, then I have it for the amount of time played. So if I go through and I look at, I'm talking about this data out here, and I just do 37 out of 124, 11 out of, and go all the way down, and then go across this way for gender. So here they are here, my gender and the amount of time played. Another thing I'd look at is called conditional distribution. And when I talk about conditional distribution, well, what's the condition? The condition is that I'm male or female. I could also do it for all of the number of times played. But really, I want to know, is there association between these 2 things? Best thing to do is create 2 different distributions. I'm going to go straight down here. The condition is that you're male. This condition is I'm female. And I create 17%, 12 out of 72, 17%, and I create these percentages here and here. And what I can do is I can create a side-by-side, this is a side-by-side bar graph, and see, is there association? And what an association would mean is that, all right, If there was no association, I'd expect these two things to be approximately the same. They'd all look the same, but obviously these things aren't. Now, the AP Stat they love these type of graphs here. This is called a segmented bar graph, and it's done the same way with the same table that I had on the other page, except here's male, here's female, and they just do them as percentages here. What would these two graphs look like if you expected there to be no association? And think about that, and then we'll talk about that.